We begin the service utilizing the ultrasonic probe. We're listening for noise generated by arcing, tracking, and corona. This provides a safety risk alert for the technician, as well as identifying hidden anomalies. Here the ultrasonic probe identifies noise within a breaker. As the technician moves further into the service, he'll give special attention to identifying what the problem is and why it's occurring. He'll then document in detail all of the data within the TEGG tasking software. After completing an entire scan with the ultrasonic probe, the technicians safely remove the cover. As you can see, performing electrical preventive maintenance is a two-person job. After removing the cover, we perform a visual inspection to identify code violations and any potential safety or performance risks. All the findings will be again documented in the TEGG tasking software. To ensure accurate temperature readings, a cover is removed to view the bus. Infrared thermographic imaging requires a line of sight to obtain any heat information. To take this one step further, the NFPA 70B strongly recommends all cover removal to obtain accurate temperature measurements when utilizing infrared thermography. We now will compare the actual load on this circuit breaker to its 90 amp rating. We will do this by utilizing a true RMS digital multimeter. We start with the A phase and see 64 amps with roughly 3.6% total harmonic distortion. Moving to the B phase, we again see 64 amps with roughly 3.8% total harmonic distortion. On the C phase, we see a slightly higher reading of 66 amp current draw and a relatively low harmonic distortion of 3.8%. So what do these readings indicate? We know that this breaker is 70% loaded and we have a low harmonic distortion. This means that the harmonic distortion is not generating any significant amount of heat. The actual heat on the breaker is between 35 and 39 C, which is within the acceptable operating parameters. If we rely on infrared thermography alone, we would have determined that this breaker is under normal load and generating an acceptable level of heat. This clearly identifies the true benefit of ultrasonic testing. The noise identified within the breaker is not generating any significant amount of heat, and therefore would go undetected by the camera. The noise does indicate that the contacts within the breaker are deteriorating. We'll verify this by taking a millivolt drop test across each adjacent pole of the breaker. We begin with the A phase. As you can see, there's a 1028 millivolt drop across the breaker. On the B phase of the breaker, it is significantly lower at 62 millivolts. And on the C phase of the breaker, it shows 71 millivolts. This test identifies a greater than 1 volt drop on the A phase contact. According to the NETA standards, this type of measurement cannot exceed a 50% deviation from one adjacent pole to the other. Our findings will now be presented to the manager of this facility. We will also include the solutions to bring this distribution panel up to its maximum efficiency.